Hello everyone, this is Mr. Ege again. This time we're going to be designing the hour arm of the mechanical clock. You already hopefully designed the front plate and the axles, 6 axles on the back side of the front plate. You already hopefully designed the second arm, the minute arm that you see on the screen. Now this time we're going to start a brand new part drawing in the inventor. Okay, and make sure that you save your drawings every 5-10 minutes or so every time you accomplish. This is going to be a third drawing in the inventor. So I'm just gonna go to file and click on new. Okay, and not that I have to do it this way, you can do it also go to the next to the top left corner and there is a new button here for the new drawing starting. Click on it too. That's one of the ways you can do it. And you go select templates. Under the templates there is EN US or English US, and then you select the English version of it. This is an inch system. There's metric system too. In the United States there are two different units, and English metric and inch system, and we're selecting English system, inch system. Standard IPT has to be selected, and then you create at the lower right hand corner. Okay, so a brand new drawing is in front of you right now. And as you know, first thing to do, go to the origin, plus buttons, and so open the folder, select your plane, and we're selecting YZ plane. After which you're supposed to start a new sketch. And this is a common procedure, repeated multiple times, okay? And we're going to be using this technique. All right, so how do we create? You have to design. How do we create the hour arm? Hour arm is the largest, biggest, and bulkier arm than, and it's also shorter too. But it's something you have to see from long distance and see approximately what time it is, approximately by just looking at the hour arm, okay? And nice thing about it is that the bulky look enables you to design something muscular and bigger, and that gets attention. So what is the dimension approximately? The second arm was 6 inches. We use 5 inches length for the minute arm. Let's go for 4 inches, okay? So that's what I want to do. Let's go to line command, okay, and select a line from the center point, go up, and this is going to be, and adjust your screen so that you can see exactly what you're drawing, okay? And this is going to be 4 inches. So enter 4, okay, and enter again to end the command. And next line is going to be an extension approximately from starting from the same 0, 0. And you can go about, say, 1 inch this way in the same direction. All right, and that's only there to help you. So let's go with start with the center command and start the circle at the center about, say, 0.5 inches diameter. Okay, that should give you an idea. I would like to make it look like rockets, but not very complicated rockets. Okay, we're not designing a rocket, we're designing an arm that resembles a rocket. So perhaps we should have some, every rocket has a sharp hand, so, or pointed end, okay? So that's what I want to do. I want to just pick a small circle, okay, and then I want to draw an arc coming out of there, okay. Zoom in and select an arc. This, kind of like that, okay. And in situations like this, mirror command is a great help. If you know the mirror command, then your design will look good. Okay, and you're done. Perhaps, okay. We should draw another arc. Having said that, didn't come out as it came out as a straight line. I'm going to just simply modify it a bit like this, and perhaps make sure that end of the lines meet. Control Z. Sometimes computer generates its own correlations, constraints, and when this happens, it does it with all the good intentions. I'm pretty sure it's just that not necessarily. It's very helpful every time. Again, mirror comment will help me at this point. The mirror line is already drawn at the center. When you apply it, it's going to show up just like that. Okay? And as usual, we're going to become efficient by just reducing some of the extra material, and I'm going to go with the offset command. All right, so we might as well have some tail fins. And there's some trimming to do. I'm going to erase some of the lines that does not help you and me at the same time, and also continue with some trimming. And that's the whole idea, what's going to look like at the end. And some of the lines are there, but they're not helping us. So I'm going to select those lines and then erase them. What they did help me and you at the end, at the beginning. So we kept them like the way. But at one point when you don't need them, you get rid of those lines. Okay. So this is all good, and maybe we should erase some of the extra lines that we don't need now. Okay. I think we're ready, except that Excel. The Excel again is a big deal, huge deal. How do we create an Excel? This Excel should be large enough to accommodate minute arm and the second arm. Okay. And being this is our arm, is the largest one and is a heavy duty Excel at the end. So I put down my notes here, and I said it's going to be 7/16 of an inch ID, OD. OD is outside diameter, and 5/16 of an inch ID. ID is inside diameter. So we're going to draw two circles and for a pipe axle, and first circle is going to be 5/16 of an inch, so I'm typing 5/16, enter. And the next circle is going to be 7/16 of an inch. All right, so 7/16, enter. All right, so this is almost there, okay? And I think we're finishing the rocket shaped our arm, and I'm going to go finish sketch. And make sure that I can see the directions. Okay, and I'm going to extrude this, starting from, oh, one more thing, I'm go back to sketch, and there's an extra line here that I don't like to have it. And this is the line that I want to erase. And there's one more line that I want to erase as well. Okay. And I think we can go ahead and finish the sketch. Okay. And there's, again, saving is a very important part of the process. You go to save as. Okay. And this time, this is our arm, so you need to type our arm. Okay. Before you do anything, make sure that you save it. Cool. And now we can go extrude. Okay. And extrusion is going to be about 1/8 of an inch or 0.125 inches. Okay. And we need to get closer, select the area to extrude. Okay. Extrude. Good. Nope, I shouldn't have this extrusion, cancel. One more time. Extrude. Okay. And 0.125 or 0.125 extrusion. Okay, select area to extrude. We need to select this part. Okay, and this part. Now we need to look at it from the back side, if possible. We can see better. Now, additional extrusion is going to be, I'm clicking on the plus button in opposite end, and the additional extrusion is going to be 2-inch extrusion. And the pipe needs to be extruded in opposite direction. Okay. In opposite direction, meaning this way. And I think it's been accomplished. The center didn't seem to be empty, and we need to empty the center also. So I'm adding a cut extrusion, selecting the center in the opposite direction. No? All right, it did not. I'm adding another extrusion for the only the center. Nope, it's not working. I'm going to cancel the entire extrusion. The reason, Control Z, because the center was not Control Z extruded properly. The sketch has to be modified. I can see why it is happening, what's happening. So I'm going to extend certain lines, okay, and then trim certain lines. Okay, so trim this one and trim this one. I think it is correct now. Still, all right, to finish the sketch, save your work, and go to extrude command, and select 0.125 inch thickness. Okay. Now we need to go add the axle extrusion. And axle extrusion is going to be 2 inches. I believe it's done now, and okay. Not cut, but actual extrusion. Cool. I think this is going to accommodate the entire thing, and we need to select the material, of course. My agenda is too strong. Okay, well, that's about it. And next class, we're going to use assembly drawing, and also we're going to focus on, after that, the gearbox system. So thank you very much for watching, and we're going to continue next class. Thank you.